Okay guys, in the last week before we talked about this example, a 2D graph freedom planner robot. So we derived everything, and as you see, we came down and I applied whatever I taught you through the Lagrangian equation, and you have the notes on part 20, and finally we end up with this equation for the robot. That's the target of this course. That's right. What was that? I'm just refreshing your mind. After doing some operations, we came as like this, if you remember, m theta double dot, this is mass matrix as I explained, c q dot, this is Coriolis, or if I talk about the language of the vibration, this is the damping, but this is Coriolis matrix, plus g, that I say gravity or stiffness. G is equal to tau. That's right. So we got that the m, the mass matrix was, if you go to the part 20, A1, A2, A3, A4, A1, A2, A2, sorry, A1, A2, A3, and the C was from the previous class. I'm continuing this, right? Let me see if it's recording. Yep. C was minus M2 L1 L2 minus M2 L1 L2 sine theta 2, right? See here, in theta dot 2 multiplied by theta dot 2, and the other element is this divided by 2, right? This divided by 2 is minus M2 L1 L2 theta dot 2 sine theta 2 divided by 2, right? And the other term is, if I want to summarize, you see that we can factor out M2 L1 L2 sine theta dot 2 divided by 2 theta dot 1 minus theta dot 2, right? So it's gonna be M2 L1 L2 sine theta 2 divided by 2 in theta dot 1 minus theta dot 2, right? This is that. Yeah, and again the same, but here we have theta dot 1, so gonna be M2 L1 L2 theta dot 1 sine theta 2 divided by 2. Here we go. This was the C, Coriolis, that's right, matrix. I hope that I did right, because I'm doing with you. So theta 2, yeah. And the G, or gravity matrix, or stiffness, as I taught you, is B1 and B2. So B1 and B2. And the torque that we are sending to the actuator of each joint is U1 and U2. That you have to design a controller, like as I said, is a PID controllers, right? So, but we have A1. A1, let me write here because I'm going to use in MATLAB, right? A1 is, where are you? A1, yeah. A1 is this term, see? This is A1. This is M1, M2 is M1 over 3 plus M2. L1 is M1, M2, L1 square, L1 square plus 1 over 3 M2, L2 square, right? Here we go. Plus M2, L1, L2 cosine theta 2 plus M2, L1, L2 cosine theta 2. You see that this A1 goes here. That's right. So we have A2 that we have in non-diagonal elements here, the both. So A2 is 1 over 2, 1 over 3, okay. It is 1 over 3 M2 L2 square plus m2 L1 L2 over 2 multiplied by cosine theta 2, cosine theta 2, and we have A3, right? A3, which is this 1 over 3 m2 L2 is m2 L2 square. Here we go, right? So let me double check, because I'm gonna insert the MATLAB. Now it's MATLAB time. M2 L1 to cosine theta 2. M2 is this. M2 L1 to cosine theta 2. See the same. And see the same. And the B, as you see, these are the B's, that's right. These are B's, see, from the previous class. So it's B1 that you're gonna put here, that's right. So B1 is m1 over 2 plus m2 is m1 over 2 plus m2, right? G L1 cosine theta 1, G L1 cosine theta 1, and plus m2 G L2 over 2 plus m2 G L2 over 2 cosine theta 1 plus theta 2, right? Right? Yes. And the B2 is m2 G L2 cosine. That's it. So B2 is m2 G L2 over 2 cosine theta 1 plus theta 2. Here we go. And see that this B1 is going here, and let me change the color. This B2 goes here, and A2 goes here, A3 goes here, A2, and A1. Right? Now we have everything. I hope that I did right. But I can double check at home and driving and everything, but I have done right. Okay? Yeah? Okay. So now, as we have this, what is this I taught you several times, and you have seen the vibration course? This is ordinary differential equation. But how we transfer it to the MATLAB? This is very easy, guys. Because your theta, this capital boldface, is a state vector of theta 1 and theta 2, that's right, two angles of the robot. So what you're gonna do, you're gonna say M, this is matrix, theta double dot, and this is vector, that's right. So is equal to tau minus C Q dot, or I'm sorry guys, this is theta. Sometimes I confuse. This is capital boldface theta, and C is a matrix, as you can see here. Minus G gravity vector, that's right. G. This is what we are talking about. So now if you want to find theta double dot from this equation, what you're going to do, because you are dealing with the matrices, you have to, come on, what you're going to do, you're going to say theta double dot is, yes, matrix inverse, that's right, from the left, that's right, this tau minus C matrix vector theta dot minus G, right? Understand? So now we can go to the MATLAB, but before going to the MATLAB, don't forget that when I say theta double dot, oh, what happens when I say, okay, here we go. when I say theta double dot means this, theta double dot means this, right? So how many state vectors you have? 4. Why 4? Because we're gonna say m1 is theta 1, m2 in MATLAB OD, that's right, theta dot 1, m3, this is a state variable, is theta 2, m4 is theta double dot 2. So on the other hand, let me write it here. So on the other hand, you say time derivative of dm1 is theta dot 1, that's right, right, look at here, theta dot 1 is m2, it is m2, but dm2, that's how we write this, right, remember, is theta double dot 1, but this theta double dot 1 you have to calculate. Now dm3 is m4, is theta double dot, it's theta dot 2, which is m4, that's right, look at here, it is m4, theta double dot, dm4 is theta double dot 2. But how, now I'm eliminating these, right, because everything must be in the state vector, that's right, the state variable, dm dot 2, dm2 is m2. What is these? We already calculated that, guys, because look at here, theta double dot vector state derivative is matrix in a mass matrix inverse toric minus Coriolis matrix theta dot vector minus gravity vector, right? So at the end of the day, look at here, guys, this is 2 by 1 vector. Look at here, you have 2 torics, it's 2 by 1 that you are sending to the joints. Gravity is 2 by 1, m is 2 by 2, so its inverse gonna be 2 by 2, right? 2 by 2. So at the end of the day, and this is 2 by 1, this is 2 by 2 in 2 by 1, result gonna be 2 by 1. So 2 by 2 multiplied by 2 by 1, you're gonna get 2 by 1, 2 by 1. So this gonna be theta double dot 1, theta double dot 2. Understand? So this, okay, whatever is this, I'm gonna, in the MATLAB code, I'm gonna say right hand side. You're gonna see this is right hand side, right, because theta double dot 1 is dm2, the double dot 2 is dm4, that's right, see, dm2 and the dm4, right? So I'm going to right hand side, so dm2 on the other hand gonna be, because right hand side is how much, 2 by 1, gonna be right hand side element 1 column 1. So right dm2 is what is equal to right hand side, as you're going to see in the MATLAB code, second row, because it's 2 by 1, that's right. Understand? This is how we say notation in the MATLAB. I hope that you know it, that's right. So now let us go to MATLAB and now simulate the dynamics of the robot. Hold on, open the MATLAB. Okay, now what we're gonna do, I'm gonna write in the MATLAB file. So I'm gonna say in the format of ODE function, m is our state variable, as you know, it's a 2DOF robot. I'm just whatever you name it. Time and the state variable, as you know. And I have 4 state variables, so you have to create space dm zeros 4 and 1, right? And I'm gonna save it as hold on. So I saved as a degree of freedom robot because 2 is ridiculous. So I'm gonna assign some parameters. Say Mass of the first link is 0.3 kilogram. Length of the first link is 0.6 meter. Mass of the second link, I'm gonna say, is 0.2 kilogram. Let me make this 5 and make it 4. And the length of the second link, I'm gonna put 0.4 or 0.35. So we have this. Now what we're gonna do, I have to write these terms, guys. I have to write these terms. Look at here. A1, A2, because you have to make this matrix and put here finally. A1 is this, and 1/3 plus M2, so you have to type it here. So what is that? So A1 gonna be, A1 is M1 divided by 3 plus M2 exactly, multiplied by what? Multiplied by L1 square. L1 square. I don't know what's wrong with this. Plus 1/3 M2 L2 square. 1/3 multiplied by M2 multiplied by L2 square. Plus, saving, plus M2 L1 L2 cosine theta 2. So that's M2 multiplied by L1 multiplied by L2 multiplied by cosine theta 2. What is theta 2? Based on whatever I said here, theta 2 is M3. See here is M3. So you're gonna say is M3. Here we go. This is your A1, right? So your A2 is this, the second part of this. So it's easy to generate that. So you're gonna say this is your A1, copy and paste. So your A2 is this. Here we go, right? Exactly the same. Second part of this is this, and A3 is 1/3 M2 L2. This is very easy. You just say this is A3, and now this is your A3, right? There we go. Let me double check everything. Until I want to, yeah. This is your A3. Get here, guys. This is your A3. Now you can now make that. You can say my mass matrix is equal to A1, A1, A2. Next line again, A2 as we said, and A3. Here we go. This is your mass matrix generated. Now let us go to Coriolis Matrix. So your Coriolis Matrix is, I'm gonna say C1. Look at here. I'm gonna say this is the C1, right? Because this is C1, C2 is C1 divided by 2. So minus M2 L1 L2 sine theta 2. So it is minus M2 multiplied by L1 multiplied by L2 multiplied by sine theta 2. As you said, theta 2 is M3 in a state variable, right? Let us see. Multiplied by theta dot 2. But theta dot 2 is M4. You see that? Theta dot 2 is M4. So you're going to say multiplied by M4. Here we go. But C2 is very easy. C2 is C1 divided by 2. See? It is C1 divided by 2, and that's it. See? And now C3 is this one, this term. So you have to M1, M2, L2, theta dot 2 and theta dot 1. So it's gonna be your C3, this is C2, sorry guys, this C3 is, I'm gonna take this out, yes, theta dot 1 minus theta dot 2, look at here, M2, L1, L2 sin sine theta 2, theta dot 1 minus theta dot 2. So here theta dot 2 is what? M2. M2 theta dot 1 minus theta dot 2. Here we go. But this divided by 2. And this is C3. Right? M2, L1, L2 sine theta 2 divided by 2, theta dot 1 is M2. Look at here, minus theta dot 2. That's right? Yes. And C4, for God's sake, is what? Is instead of theta dot 2, theta dot 1 here only. Right? So I'm gonna copy and paste here. And divided by 2. Here we go. This is C4. You got here M2, L1, L2 sine theta dot 2, theta dot 1. Theta dot 1 is M2. The only difference is this. This is divided by 2. This is divided by 2. This is divided by 2 as we did, and but this is minus. These are plus and plus. All of that is right. So your Coriolis matrix is gonna be C1 as we said, C2, next line, C3, and C4. Here, bingo. Now let us go to gravity. So you have to say B1 because your B1 is this. Look at here. And 1 over 2 G L1 cosine theta 1. So it's gonna be M mass 1 divided by 2 plus M2 M underline 2 multiplied by G, and we have to define G in gravity. Say G is 9.81 millimeter per second square. G multiplied by L1, see here, L1 cosine theta 1. Theta 1 is M1. Multiplied by cosine M1. This is state variable. That's right. Plus M2G L2 over 2 cosine theta 1. So it's gonna be plus M2 multiplied by G multiplied by L2 multiplied by cosine theta 1 plus theta 2 M1 plus M2 theta 1 plus theta 2 divided by 2. Here we go. Right? Here we go. And B2 is second part of that. So B2 is, get here, B2 is this, simply like that. See, M12. So now your gravity matrix G is gonna be B1, see, and the next line is B underline 2, right? Now we have, I'm writing here as a comment, please do at home, okay? It's gonna be mass matrix, this is gonna be Coriolis matrix, right? And it's gonna be gravity vector, and you can extend this to any degree of freedom robot, 3 degree of freedom, but you have to expand that even for the 7 degree of freedom backslash I in my lab, right? So now you have to go to the state variables. So dm1 as we used here, see M1, dm 1 is equal to M2. This is how we define. Let's go to the first class that I was teaching the inverted pendulum. And dm2 is equal to what? The dm2, as I told you, is, guys, is a right hand side 1 and 1. So we have to first make the right hand side. Right hand side, I'm exactly typing here. Guys, look at here. Right hand side is equal to, look at here, there's no magic. Inverse of M, mathematics. Inv of M multiplied by what? Multiplied by torque, I say tau is the vector, that's right, minus C, Coriolis C, multiplied by what? As I taught you, look at here, guys, this is C, theta dot 1, theta dot 2. So you have to say, look at here, M2, right, and M4. Here we go, right, minus, look at here, guys, minus G, gravity, minus G, right? So this is the right hand, this is M4. Here we go. I hope that I did everything right, huh? Let me double check everything. I will double check at the end, okay? So now the M2 gonna be right hand side 1 and 1. Here we go. Now dm3, as I defined the state variable, is M4, that's right, and dm4 gonna be what, as I taught here, gonna be right hand side 2 and 1, the second line of that, because it's 2 by 1. This is algebra, huh? Gonna be right hand side, and 2 and 1, because it has 2 rows and 1 column. Here we go. But the problem is that we have everything except tau. So I'm gonna say tau here is 0.3 whatever. This is random. A periodic torque, sine of t. I mean this is the for first. Second is a different. This is 0.4 cosine of, I don't know, 5t, and this is 2t with different frequencies. Suppose I'm sending a periodic torque to the joints, that's right? So now let me double check everything. M1, L1, M2, L2, G. Let me see these. Okay, here we are. So this is gonna be M1 over 3 plus M2 in L1 square plus 1 over 3 M2 L2 square plus M2 L1 L2 cosine theta 2 30. A2 is the second part of that. A3 is this. A1, A2, A2, A3. Your C is minus M2 L1 L2 sine theta 2 in theta dot 2 is divided by 2. Double check that if it is right, because yeah, it is. So here we go. C3 is M2 L1 L2 sine theta dot 2 in multiplied theta dot 2 and theta dot 1 and theta divided by 2. And this is everything the same except that it is theta dot 1, and B1 is M1 over 2 plus 2G cosine theta 1 plus M2G L2 cosine theta 1 plus theta 2 divided by 2 and B2 is M2G L2 cosine I2, and this is the things, and inverse of M, right? Okay, now what we're gonna do, I'm gonna do that this total time and the all state variables. I'm gonna use OD45, and I'm gonna call degree of freedom robot, gonna give time from 0.1 to 10, and I'm gonna give 0, 0, 0, 0 as initial position velocities of the links. And now I'm gonna close it, and I'm gonna say figure one, I'm gonna say plot all the time and the angle of the first link of the robot as blue line, and the angle of the second as a red, and grid. Oh, hold on. And okay, so I saved as sol. You see what I'm saying? But these are in the radians, that's right. I have to make it in angle, so I have to multiply it by 150 divided by pi and 150 divided by pi to see the degree. You know what I'm saying? First, let me debug it, because yeah, I always have oh, there's a mistake here. This is degree of freedom or not degree of, this is what we get. Okay, what's the mistake? Dimension of arrays. Oh, shows, oh my god, there's a typo here. How do you have to debug? It happens when you're teaching. So you see that now I can see what happened. It says failed at this time t, because this is singular. Okay, let me double check the numbers. Okay guys, it was two typo. First, that this is theta 1 plus theta 3, theta 1 plus theta 2, but theta 2 is M3 and this is M1. I fixed that, I debugged it, so it's M1 plus M3. These are the state variables you see here, same here. Another that I found is here I had 2 divided by 2, see, A2. That's why we had the singularity, see, this is divided by 2. So now if I say my torque is 0.2, a periodic torque to the joint 1 in T, and if I say I have another periodic torque, these are just examples, and for 2T, that's right. Now if I say all of them starting from 0, 0, 0, 0, I hope that once. So for 10 seconds, if I run it, you see that I have such a stupid behavior of the, see that the second is going to minus 30,000 degree, the second link, that's right. But the first link gonna oscillate around that corner. So so even that I decrease this to 0.1, so here we go. You see that the first is oscillating around, I don't know, 100 and these kind of things, but second gonna be this unstable. That's right. So we can now, we did model. Let me put it here, because in the next class I'm gonna teach you legend. The first is theta 1, and the second is see, theta 2, right? Here we go. See that? Okay, this is the blue line is the link of the first, and this is the link of the second, so it becomes unstable. So now what we're gonna do in the next class, you see that we're gonna design PID controller for that. Controller for the robot to follow a desired trajectory. This is what we're gonna do. Okay, next class. I hope that everything is right. Or if I change this 6.6 and like this, I just want to examine the numbers. See that this time goes up. Okay, so if I see I can just want to make it more sensible. Yeah, 10,000, it's gonna oscillate forever. So this is not good. So we have to do it as 0.1 now this time. Yeah, this is more logical now. See that the first link gonna oscillate around this, right? And the second link gonna oscillate around that. So, okay. So now this is how we model the dynamics of a robot. Understood? And that's it. Let me double check everything, and next class I'm gonna teach you how in the MATLAB you design the PID controller. Okay, so that's it. So next class I'm gonna design PID controller, and we are done with the course.